All right. Good evening. This is your systems of linear equations review from our stations review today in class. I'm going to work out each problem and try to give you some helpful hints on things to remember. I'm going to start with a graphing one. You may have not have started at station 3, but you definitely have that one. So look at your graph paper that you used today in class. The first thing that we always need to do is make sure that it is in slope-intercept form, which is y equals mx plus b. And then we need to identify our slope, which is m, and our y-intercept, which is b. And both of our equations are in slope-intercept form. So I'm going to identify my slope, which is m. It's negative 1/2. Don't forget your negative. Then I'm going to look at my b, which is my y-intercept, and it is a negative 1. I'm going to go ahead and do it for the next equation, which is 1/4 is our slope and negative 4 is our y-intercept, or b. Remember, you always start with your b for your starting point, and then you use rise over run for your slope, and be careful of your signs. So I'm going to go ahead and start plotting these. I'm going to use two different colors. I'm going to take my bracelet off so I can do this. So I'm going to start off at negative 1, which is right here. And then I'm going to go, remember this is rise over run, so I'm going to go down 1 over 2. Down 1 over 2. Now, I know this line extends past this negative 1, so to keep my negative 1/2, I'm going to go up 1 and over 2 to the left. Up 1. Did I do that? Up 1 over 2. Yes, up 1 over 2. And then we can connect. Don't have a ruler. I should have a ruler out. Okay, so I started at negative 1, down 1 over 2, up 1 over 2. So now let's look at the other equation. I'm starting at negative 4. And I'm going to go, both of these are positive, so I'm going to go up 1, 1, 2, 3, 4. Well, look at there. Right off the bat, we find where they intersect. So our intersection is at 4, negative 3. That is the solution for this problem. Now remember, when we are solving systems, we are looking for the point of intersection. That is the solution. This is the prep work for that. Okay? So that is where they cross. So we go 1, 2, 3, 4, 1, 2, 3. So our x value is 4, our y value is negative 3, and that is their point of intersection. Okay, let's look at the next one. Same scenario. We have y equals 4x plus 3 and y equals negative x minus 2. We need to make sure that it is in y-intercept form, and they both are. And then we need to identify our slope and our y-intercept for both equations. In our first equation, it is 4, but if we want rise over run, we'd put that over 1. And then our next one is 3. Our y-intercept is 3. Let me erase this right off here. I'm just using the ones that y'all had on the desk today. All right, so let's look at our slope for this. Now, you notice there's not a coefficient there or a number, so that means that that's an invisible 1. So we have a negative 1 over 1. Then for our y-intercept, we have negative 2. Okay, so let's go ahead and graph. I'm going to start at 3. And I'm going to go 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And you say, well, Miss Smith, that doesn't make any sense. You went down and to the left. Well, if you remember, I'm going in the negative direction, and then I went in the negative direction on the x-axis. So if I have a negative y over a negative x, that equals a positive y over x, because a negative divided by a negative is a positive. You'll see in just a second where they intersect. I should get me a little, maybe this will work. Okay, see if I can get that lined up. All right, so we have this line. Now let's go ahead and graph y equals negative x minus 2. Excuse me. I'm going to start with my y-intercept, which is negative 2, right here. And then I'm going to go a negative slope of 1 over 1. So I'm actually going to go up 1 over 1. Look at there. Bam. There it is. That's where they intersect. If I went down 1 and over 1, there's my line. But we can already see where they intersect. Okay. So our solution in this problem is going to be negative 1, negative 1. Okay. I don't know if I'm running out of ink there. Surely not. So that would be our answer. Negative 1, comma, negative 1. There's our x value and our y value. That's the point of intersection. Okay, remember guys, you always have to make sure that it's in this form, in slope-intercept form, and then you need to identify your slope and your y-intercept, and always start with the y-intercept before you start doing your slope. Okay, move on to the next station. Station 2 says solve each system by substitution. Okay, so let's go ahead and look at this first one. I'm going to work it out to the side here. I have y equals x minus 1. Well, I'm going to plug that in for that y right there. It may not be a single numerical value, but I am substituting in what y equals, the value of it, and it is x minus 1. Okay, so I'm going to rewrite 2x minus 3, open parentheses, x minus 1, close parentheses, equals negative 1. Then I'm going to distribute the 3 through the parentheses. So I have 2x minus 3x plus 3. A negative times a negative is a positive. And in this particular problem, watch your signs. Equals negative 1. Now I'm going to collect like terms. 2x minus 3x gives me negative x, or negative 1x, plus 3 equals negative 1. I'm going to subtract 3 from both sides. I get negative x equals negative 4. Now there's a negative invisible little 1 sitting right there. We want to get rid of this negative, so we divide both sides by negative 1. Therefore, x equals 4. Now that's only one part of our solution. We need the x value and the y value. Well, this happens to be pretty easy because now we just take this x value and plug it back into this equation right here, and we get y equals, look here, 4 minus 1, y equals 3. So our other value is 3. That is our final answer, 4, 3. That is the point of intersection. Okay, let's go down here and work on the other one. We're still working with substitution. Remember on your test, you're going to have to do each way, and then you'll have some problems where you get to choose the way that you want to work the problem. Now, this one isn't like the other one because we don't have a y equals or an x equals, but we have to put it into that form. So I'm going to work with this one. Because what I do is move that over. So I'm going to rewrite, and I'm going to add 2y to both sides. I get x equals 2y plus 11. Now I have it in x equals form, so I can take this and plug it in where I see x to get my equation into one variable. So I'm going to plug that in, negative 7 open parentheses, 2y plus 11, close parentheses, minus 2y equals a negative 13. Okay, now I need to work our parentheses. So I'm going to distribute the negative 7 through. Okay. Now I need to collect like terms. Negative 14y and a negative 2y is negative 16y minus 77 equals negative 13. I'm going to add 77 to both sides. If I do it to one side, I have to do it to the other. And I get negative 13 plus 77. So that gives me a positive 64. Okay, and then I'm going to divide both sides by negative 16. So we know a positive divided by a negative is negative. And so 64 divided by 16 is 4. So we have a negative 4. So there is part of our solution. Negative 4, there's our y value. Now, since I have found this y equals negative 4, I can take that back up and put it into one of the original equations where I see y. So I'm going to do that over here. I'm going to plug in my negative 4. Multiply through. Negative 2 times negative 4 is a positive 8. I'm going to subtract 8 from both sides. X equals 3. Okay, move that up. So now I bring that up here. I have my x value. There's my final answer. That is the point of intersection. Now there was a lot of signs in that we needed to remember our sign rules. So be sure that you are watching what you're doing. I don't want you to mess it up just because you missed a sign. Okay, so that's station 2 by substitution. Let's go to the next one. Station 1, elimination. A lot of y'all like elimination. This is pretty easy on both of these. Remember, we are trying to eliminate one of the variables to be able to solve for the other one. So negative 4x plus 4x gives me 0. Negative 2y plus 8y gives me 6y. And negative 12 and negative 24 gives me a negative 36. I divide both sides by 6. Then y equals negative 6. Now, of course, what do I need to do with this value for y? I come back up here. I plug it back into an original equation. I can work it back out in terms of x. Okay. Negative 4x, negative 2 times a negative 6 is a positive 12 equals negative 12. I subtract 12 from both sides. Now, a lot of you get messed up right here because you don't want to add them together. You think 12 minus 12 is 0. No, not how that works. When we have the same sign, we keep the signs and we add them together. So we have a negative 24. Divide both sides by negative 4. X equals 6. Okay? Feeling good so far? Most of y'all really like elimination. Let's look at the next one. Kind of works the same way. Maybe I should have varied it up where you had to use a different method on this, but we did that in the word problem. So let's keep going. Negative 6x plus 6x is 0. 5y plus 4y is 9y. 1 minus 10 is a negative 9. Divide both sides by 9. Y equals negative 1. Okay? Go over here. There's my y value. Now we just have to put this back in for y. So now I don't have a lot of room. I'm going to move over here. Negative 6x minus, well, that's a plus, 5 outside of negative 1 equals 1. Negative 6x minus 5 equals 1. Add 5 to both sides. Negative 6x equals 6. Divide both sides by negative 6. X equals, I think there's tape there as well. That doesn't want to work. X equals negative 1. So our x value is negative 1. Our y value is negative 1. There's our point of intersection. There's a solution to elimination for those two linear equations. Okay, last but not least, the dreaded word problem. I know y'all go, oh, Miss Smith, I can't stand a word problem. Our life is a word problem, guys. Yeah, Miss Smith. Yeah. You just keep talking that. I know how y'all are. We've done one similar to this in class about tickets. This was the one that you could use whichever method you wanted to. Of course, on the board, I had started it using substitution, but you could also use elimination. So what we need to do is first we need to read the problem and figure out what information we have here, because this just doesn't give us the equations themselves. It says the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. So we need to look right here. When we see total of, that's equals. Okay? And then the school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. So our total is $52 that time. So we're looking for the price of the senior citizen ticket and the child ticket. So let me move my paper over here so we can see. And I'll start. Now I'm going to do this by elimination first. Because so many of y'all love elimination. I'm going to write my 2 equations, which my first one, and I'm going to use S for senior ticket and C for child ticket. You can use whichever variables you want to. So we have 3S plus 1C equals $38. There's our first one. Then we have 3S plus 2C equals $52. Okay? Now, you can approach this several ways. I used subtraction. I had another student who multiplied the top by a negative 2. Either way is correct. So I'm going to subtract. And remember, when I put the subtraction out, it's really changing the sign of each one of these. So I'm going to rewrite so that I don't mess up along the way with my signs. So now I'm using this equation and this equation. 3S minus 3S is 0. That eliminated. 1C minus 2C is minus 1C. 38 minus 52 is a negative 14. Divide both sides by negative 1. We sold 14, or let's just find the price. The cost of the children's ticket is $14. Okay. Now let's take this 14 and plug it back into the original equation. So I'm going to use this one right here. And I'm going to write 3s plus 14. Because it's 1c, I'm plugging this back in for c. There's the value of c. In all actuality, we're substituting. Okay, subtract 14. 3s equals 24. Divide both sides by 3. S equals $8. So a senior ticket is $8 and a child ticket is $14. There's your answer. Okay, I'm also going to show you how to do this using substitution. Okay, same equations. This time we're by substitution. I have 3s plus 1c equals 38. Then I have 3s plus 2c equals 52. Now, my eye immediately went to this right here, that I could just move that over and have solved out for c. So I'm going to do that over here. I'm subtracting 3s from both sides. And I get 1c equals negative 3s plus 38. I'm going to rewrite this. And I'm going to plug this c value in where I see the letter c. So we have 3s plus 2 open parentheses minus 3s plus 38 equals 52. Then I'm going to distribute the 2 through the parentheses. Excuse me. 3s minus 6s plus 76 equals 52. I'm going to collect like terms. 3s minus 6s is a negative 3s. I'm going to subtract 76 from both sides. So I get negative 3s equals negative 24. Now see, isn't that starting to look a little familiar? We went back up and looked. Divide both sides by negative 3. Senior ticket is $8. Okay, look here. Senior ticket was $8. Child ticket, $14. I bet you the child ticket's still going to be $14. What do you think? Okay, so I take this, and I'm just going to take it and plug it back into this one because we solved it out for C, so it's going to give us the direct cost of a child ticket. So I'm going to rewrite 1C equals negative 3 outside of 8. I shouldn't say outside of, I should say open parentheses, 8 close parentheses, plus 38. C equals negative 24 plus 38. C equals negative 24 added to a 38 is going to give us 14. So once again, a child ticket is $14. A senior ticket is $8. Same answer. I would tell you to study these examples. Your test will be very similar to this. It will not be identical, but it will be similar. If you have any questions, of course, you can ask me on Remind. Please don't be trying to ask me after like 9 o'clock. If you must, please don't pass 10 o'clock. Otherwise, you can see me in the morning if you have any questions. Good luck, study hard. I'll see you tomorrow.